Hi everybody, this is lesson 1 of circles. So we're going to go through some definitions here. First one is, what is a circle? A circle is a set of all points equidistant from a given point. That given point has to be the center of the circle. And a lot of times they'll put a letter right there. So I would refer to this as circle A and write out the word circle, or sometimes they draw a little tiny circle with a point in the middle like that and they say circle A. So if you ever see that notation. A radius, you should be familiar with. A radius is a segment that joins the center of the circle with any point on the circle. So from the center to any point. Okay, right there is a radius. So if I put like a 10 here, my radius equals 10. Now the radius doesn't have to go to the right like that. Generally that's where I draw it, but it goes to any point on the circle. So there's tons of radiuses in a circle. Like I can draw a radius here, and all the radiuses have the same length. A diameter is a segment that passes through the center and whose endpoints are on the circle. So this right here is a diameter. If the whole line is drawn, then I know that's the diameter. And we know this from when we were doing area of circles. So if my diameter is 20, my radius is half of the diameter. My radius would be 10. Right? Chord. So this is a new word that we have, something that you haven't run across before. A chord is a segment whose endpoints are on the circle. All right? So if I have a circle, a chord has its endpoints on the circle. So that right there is a chord. All right? Is the diameter chord? It absolutely is a chord. It's the biggest chord in a circle because it goes through the center. But a chord is just a segment whose endpoints are on the circle. Central angle. So this is something we're going to talk about a lot tomorrow. So it's an angle whose vertex is the center of the circle. So if I have the center of the circle and then I have that angle right there, that is a central angle. The vertex is in the center of the circle. And then, of course, you already should probably be familiar with semicircle. So a semicircle is just half of a circle. So if I'm just talking about like this half of the circle, all right, that's a semicircle. I'm going to highlight central angle, because that's a new one also. All right, so chord's a new word, central angle's a new word. Semicircle you should already be familiar with. Arc. Arc is going to be a new word also, and inscribed angle is a new word. So an arc is just a portion of the circumference of the circle. So you guys know that the circumference of the circle is like the perimeter. It's the distance all the way around the circle. So if I just want a part of that, okay, so say I do something like this, and I'm just talking about this part right here from A to B. So I write the A and the B next to each other, and I do a curved little arc mark above it. Just like with line segments, I would do a straight line. Well, this is curved, so this is arc AB. It's a portion of the circumference. And then I have an inscribed angle. So central angle and inscribed angles, that's going to be our lesson for tomorrow. We're going to spend a whole day on them. So an inscribed angle is an angle that has its vertex on the circle. Like that. So that's an inscribed angle. An angle whose vertex is on the circle. So the vertex of the angle is right here. It's on the circle, where a central angle, the vertex was in the center of the circle. Okay. Let's go to the next page. This we already did. This got on there twice for some reason, so we don't have to worry about central angle again. But we were talking about arcs, and an arc is like a part of the circumference of the circle. There are two kinds of arcs, a minor arc and a major arc. So a minor arc is an arc that has a measure less than 180 degrees, and a major arc is an arc that has a measure greater than 180 degrees. So if I have an arc like this, that is a minor arc because it's less than 180 degrees. Now, how do I know it's less than 180 degrees? Because a total circle is 360 degrees. If I have half of a circle, like a semicircle, that's 180. So this is definitely less than 180 degrees. A major arc is more than 180 degrees. Now the difference for a major arc is that I need to have 3 letters so that I know I'm going the long way around the circle. So if I want to talk about this part of the circle, that arc, I need 3 letters, and I would call it arc ACB. All right. So that's the difference between the major arc and the minor arc. Major arc, I need 3 letters. Whoops, need 3 letters. So this way I know I'm going the long way around, and it's a major arc. An intercepted arc is just an arc cut in the circle by an inscribed or central angle. So that's also a new word. So say I have a, I'm just going to do a central angle. All right, so I have angle ACB. All right, so I have angle ACB is a central angle. Angle ACB has arc AB as its intercepted arc. And I'll just highlight that instead of using the red. So arc AB is the intercepted arc. The beginning and the end of the arc are where the sides of the angle are. Okay, so that's the intercepted arc. It's an arc cut in a circle by an inscribed or central angle. All right, secant, definitely a new word. Tangent, a new word. And point of tangency is a new word. So a secant is a line that intersects a circle in exactly 2 places. All right, so if I have a line like this, that secant intersects the circle in exactly 2 places. That's a secant. Oops, I did it in the wrong spot. Sorry, guys. That is not a... All right, so secant, let's do that again up here. So a secant is a line that intercepts a circle in exactly 2 places. All right, where a tangent is a line that intersects a circle in exactly 1 place. All right, so if I have this line right here, all right, and actually I didn't do a great job because it looks like it's going through there more than once. Let me try that again. All right, so if it intersects a circle in exactly 1 place, that's a tangent line. The point at which the tangent line intersects the circle, that is called the point of tangency. All right, so I'll just draw another one down here. So the point at which it touches the circle, that is the point of tangency. All right. Just a review of our formulas. So area of a circle is pi r squared. We'll be using them in this unit also. And circumference of a circle is either pi times diameter or circumference is 2 pi r. All right, and then we just have some problems to look at using that new vocabulary. All right, so identify the following using the vocabulary from the opening exercise. So A, B, C, and D are all arcs. We just have to decide if they're a major arc or a minor arc. Also, if it's exactly 180 degrees, then I'll call that a semicircle. So I can highlight these. So I got arc BE. All right, if it's less than 180 degrees, it is a minor arc. So I know 180 degrees is the half a circle, so this is a minor arc. Arc CDE. I'll do that in green. CDE. So I start at C. I have to go to D next and then E. All right, so CDE. Oh, look, that's exactly a half a circle, so I would call that a semicircle. I know it's a half a circle because CE is a diameter. It goes through the center. So that's how I know that's a half a circle. Arc EDF. EDF. So, oops, I wanted a different color, sorry. EDF. So where is EDF? Okay, so E, and then I got to find D, and then I got to find F. Well, that's less than 180, so that is a minor arc. And so even though I have the 3 letters, does not necessarily make it a major arc. It has to be greater than 180 degrees. Next one I have is arc FED. FED, so F, and then E, and then D. All right, so I can't go the other way from F to E because I would pass D, and E has to come first and then the D. So that is definitely more than 180 degrees, so that is a major arc. All right, and then my angles are either central angles if the vertex is in the center of the circle, or an inscribed angle if the vertex is on the circle. All right, so let's look at what I have. Let's get another highlighter here. Let's do orange. So angle BAE. So BAE. The vertex is in the center of the circle, so that is a central angle. angle BDC. Do that in red. So BDC, so this way, B, and then D, and then C. Okay, so that is going to be an inscribed angle because the vertex is on the circle. And that one I had in red. And I am running out of colors here. I could do gray. Angle ECF. So angle ECF. So E starts here. Oops. E. The gray doesn't really show up. Oops. Oh no, because I went to that. All right, sorry. ECF. All right, that's another inscribed angle because see how C is on the circle? So that is an inscribed angle. Okay. All right, here we go. Draw a point on the circle and label it D. I can put that point wherever I want. I'm going to put it right here. All right, create angle BDC. So I'm going to go from B to D and then from D to C. All right. BDC is called an inscribed angle. Explain why. The vertex is on the circle. Okay, D is on the circle. Draw an angle formed by connecting points B and C to the center of the circle. All right, so I'll do that in blue. So B, A, and then C. Okay. Is BAC an inscribed angle? No. Okay, BAC is a central angle, and that's the next question, but it's not an inscribed angle because the vertex is the center of the circle. Is BAC a central angle? Yes, because the vertex is the center of the circle. What is the intercepted arc? Remember, the intercepted arc, the beginning and the end of the arc match up with the sides of that angle. So the intercepted arc is actually arc BC. Okay, now I don't have a way to measure this with a protractor. I did it on my paper. So angle BAC right there, when I did it on my paper, angle BAC was 75 degrees. And then I measured angle BDC with my protractor, okay? And angle BDC was 37 degrees. Make a prediction about the relationship between those angles. Well, you can see that BAC was bigger than BDC. So the central angle, they both have the same intersected arc. And we're going to learn tomorrow that an inscribed angle is half of the central angle. So that's the rule that we're going to learn tomorrow. And this, again, it's almost half, because if I had measured like to the nearest tenth, it would have been. All right, but the inscribed angle is half. Inscribed angle equals half of the central angle. All right, and we were going to practice all that tomorrow.